Welcome to Speak Life with Dr. Amy Chai. Information for your best life. Now, here's Amy Chai.
Hi, everybody. I'm Dr. Amy Chai, and welcome to Speak Life. Today, we're going to talk a little bit more about how we know what to believe when it comes to our health, and specifically what to believe when it comes to vaccine science and COVID-19. And this is a totally legitimate question because we've really tended to lose a lot of faith in the past few years in our media, in our politicians, and it's becoming harder and harder to know what to believe. So I'm going to share with you how I decide what to believe and how I work that within my practice with my patients. And hopefully you can use some of these tips yourself as you try to think through the pros and the cons of what's been going on the past 3 years with the COVID virus. So let's get started. First, I'll tell you a little bit more about myself. I have a biology degree from Johns Hopkins. And I am an internist. I went to medical school and then I did a residency in internal medicine. And after that, I've done a couple of fellowships, including care of the complex patient in academic medicine, as well as addiction medicine. In addition to that, I spent 2 years studying something called epidemiology. Now, during the COVID vaccine and the COVID virus news that we've heard, you've probably heard a lot about epidemiology, but I actually am an epidemiologist, so I'll explain a little bit about what I do with my epidemiology training. So let's just use the example of seatbelts, okay? Now, I remember when it wasn't mandatory for people to wear seatbelts in the car. As a kid, we did some really crazy things. I remember sitting in the back of a pickup truck while the pickup was like bouncing over gravel roads. And, we didn't think anything of it. Like, hey, we might fly out of the back of the pickup truck, and that would be very bad. But that was before car seats and pickup. And seatbelts were mandatory in state laws, and now they are. But I remember way back in the day, there was a lot of discussion about the risks and the benefits of seatbelts. And let me just talk you through it a little bit. Now, people tend to overestimate the risks and underestimate the benefits when they're talking about risk and benefit. Now, in medicine, there's no intervention that we do. There's no medicine, there's no surgery, there's no procedure. Nothing that we do is without some sort of risk. And what we do as physicians is we try to balance, what could be the harms of this treatment versus what could be the benefits of this treatment. For example, if you're going to have bypass surgery to correct some clogged vessels to your heart, the risk could be that you might bleed to death or you might die during the operation. And that's a very real risk. That's why people don't like surgery. It's kind of scary. But the benefit is that it would heal the blood vessels and then you'd have good blood flow to your heart. So we balance the risks and we balance the benefits whenever we make any kind of important medical decision. And that goes with any kind of treatment at all. Now, bringing this back to the seatbelt analogy, I remember some people had heard of a family member. Let's just call him Uncle Joe. So Uncle Joe had been in an accident where the car had caught on fire. And Uncle Joe was able to escape the fire and survive. But the police officers had said, oh, it's very fortunate that you were not wearing a seatbelt, because if you had been, you might very well have been trapped in that burning car. So people were thinking about, oh my goodness, seatbelts can be dangerous, because what if you're trapped in a burning car? Or what if you drive off into a body of water, like off a bridge into the ocean, and you're trapped in the car? So there was the trapped in the car faction versus the I don't want my head to go through the windshield faction. It's true. Sometimes wearing a seatbelt causes a death. It's true. For example, there may be one person who dies in a car fire because they cannot escape from their seatbelt. But on the other hand, there's going to be 100 people whose head doesn't go through the windshield because they are wearing a seatbelt. So you see, on the one hand, there's the risk. On the other hand, there's the benefit. And what we see is that the benefit greatly outweighs the risk. And that's why we have seatbelt laws today. So when I look at risk and benefit, I look at numbers, I look at statistics, and that's how I get my answer. But most of us, we kind of get our information from friends, from family, or from a certain information bubble that we have on the internet that sort of, it limits our view of the full picture, sort of like a horse that has blinders on. They can only see like straight ahead, but they can't see what's on either side. So there is a risk to having limited information, limited discussion about risks and benefits. So let's talk a little bit about science. Where do we get science? How do we know about science? Well, let me just talk to you first with this journal that I happen to have. It's called JAMA. This stands for the Journal of the American Medical Association. Now, how do we get articles in this magazine? This magazine is very reputable because if you want to get an article published in this journal, it has to go through a very strict vetting process, and that's called peer review. So every article in this journal has been very carefully read by experts who have no conflict of interest in the outcome of the article. And if the person does have a conflict of interest with the outcome of the article, they will be asked to be recused from reviewing that article. And it's also interesting to look, I'll just open up this page here. There's a study about this medication, and this medication is called ticagrelor. Okay, so this medication is, they're talking about whether or not this medication helps with a certain type of procedure. So to get published in this journal, you have to do something called a conflict of interest disclosure. So the author of this article must disclose any sources of his funding, okay? And this author states that he received institutional research grants from Vascular Graft Solutions, and there were no other financial supports for this research. So what is Vascular Graft Solution? It is a medical device company based out of Tel Aviv. Does this company make ticagrelor? No, it doesn't. So the people who funded this gentleman's lab did not have anything to do with creating any type of funding for the drug that this article is talking about. So every single article in here, you have to find out where the person gets the money to do the research. And that way you can always follow the money. It's very, very important to do so. And people are absolutely correct to say, follow the money. And that's why in reputable journals, you will always see where the authors get their money to do their research. And you can help to determine whether or not that research might be biased or might not be biased. And we have that. But let's talk about another source of information. And I'm going to pick on Dr. Mercola today. Now, I don't know if you have heard about Dr. Mercola, but he is an osteopathic doctor who no longer practices any kind of medicine because he's too busy making $3 million a month off of his website. And how does he make his money? He makes his money by driving traffic to his website where he sells supplements and other type of devices that are unproven. And that's how he makes a lot of money. He's worth well over $100 million. And he's profited tremendously from the COVID-19 epidemic by posting articles questioning all the science about COVID-19. Now, does he have any research background? No. Does he have any fellowship training? No. Does he know what he's talking about? No. He is a businessman, pure and simple. And there's plenty of money to be made from giving false information on the internet to susceptible individuals. So Dr. Mercola, he has an entire team of employees that post provocative questions online to see which provocative questions get the most clicks to drive traffic to his website where he sells snake oil. So if you follow the money about COVID-19 anti-vaccine propaganda, what you're going to see is that a lot of it comes from people who are getting very, very, very rich off of scaring people about vaccinations. So Dr. Mercola is a person who profits from misinformation. And I wouldn't believe a word he says ever. I'm sure sometimes he's right, just like a clock that's broken would be right twice a day. But certainly I would not believe anything that Dr. Mercola says because he's quite frankly a charlatan. He doesn't have the background. He's not a researcher, and he profits tremendously from his provocative questions where he questions legitimate scientists. So if you're going to follow the money, it will lead you actually to Dr. Mercola's door, and it will lead you to the vaccine information that people are paying for with their lives. So, like I said, there's definitely a lot of misinformation about vaccines. But like I also said, vaccines do come with very real risks. And so it's important to know what the risks are and also what the benefits are to taking a vaccine. So I've told you a little bit about how I think about science, how I think about epidemiology, how to tell, what research is good research and what research isn't really research at all. And just to lead you from there into thinking a little bit more about precisely what risks are there from the COVID-19 vaccine. And yes, they are risks. And we need to figure out what's a legitimate risk, what's not a legitimate risk. And in the last video, remember, we talked about probably the number one thing that people were frightened about was that so the vaccine is going to get into your DNA. And remember, I showed you the zipper. The zipper represents DNA, and this zipper represents messenger RNA. And everything about these molecules is different. And in the human body, it's not possible to turn mRNA into DNA. It's physically not possible. So the idea that somehow the mRNA vaccine is some sort of gene therapy is completely and utterly false, which you can simply learn if you know anything about DNA, if you know anything about RNA, if you know anything about cell biology at all. So no, it does not affect your DNA at all, although viruses can and do infect your DNA. So what about the vaccine? Now, last time I showed you this picture where I talked about how T cells and B cells recognize virally infected cells. And that's because virally infected cells will chop up the viruses and they will display them on the outside of the cell in such a way as these immune cells recognize them as diseased cells, and then they'll kill the diseased cell. Now, an mRNA vaccine is not a spike protein. It's not alive. It's not part of a virus. All it is a small piece of mRNA that codes for one single protein. The protein it codes for is actually the spike protein. And the spike protein itself, after the vaccine, never enters your bloodstream. That's actually not possible because what it does is it sticks to the membrane of the cell that makes it. So these little bits of mRNA, if they do survive or if they do get into the bloodstream, they don't contain any spike protein. The spike protein only comes about when the vaccine gets into the cell and creates the spike protein to stick onto the cell surface. So you won't see any spike protein floating around in your blood. And what you will see is some cells that express this spike protein on the surface. And these cells only live for a few days because these immune cells come in and they kill these cells. And then your body chews it up with these special white blood cells called phagocytes. So everything that is in the vaccine will be gone from your body very quickly, okay? And then you'll have these little proteins that create the immune response. Now, this vaccine was really so genius that I actually did volunteer to be a person who tried the vaccine out. So I volunteered for the Moderna vaccine trials when it was in its trial phase. That's how much I believe in the science behind this mRNA technology. I think it's actually really great technology, and it has tremendous potential for a lot of other amazing applications in the future, possibly even cancer treatments. So the mRNA vaccine strategy, I think, is going to be awesome. And I'm very excited about it and what's going to happen in the future. Now, I told you that I talk about numbers a lot when I do epidemiology. So I want to get in the back of my mind, what numbers are important for you to know if you're going to think about whether or not you should get a vaccination. Now, let's just imagine I live in a small town. There's maybe 10,000 adults, right? And a typical small town hospital may have 5 intensive care unit beds for adults, and it probably doesn't have any intensive care beds for children. So, and that's for a little town like mine with about 10,000 adults. Now, what happens if there's a serious disease that comes along and 5% of those 10,000 people become ill? Well, 5% of 10,000 is 500. And so, if only 5% of people become infected with something like the COVID virus in a town, small town, that would mean 500 infections. Now, what happens if 2% of those people who are infected with the illness require an intensive care unit bed? Well, 2% of 500 is actually 10. So you would need 10 intensive care unit beds to treat all the people who were sick from the virus. Now, I already told you we only have 5 intensive care unit beds in the small town hospital, and there usually isn't any surge capacity. So, what if you had a heart attack? What if you had pneumonia? What if you had hyperglycemia, severe diabetic reaction? There's not even enough beds for all the people who have the virus. So you can see how quickly the hospital system can get overwhelmed if a large number of people become infected. And that's exactly what happened in COVID. In fact, some of our physicians in our healthcare system didn't leave the hospital at all for 3 and 4 months because we can't make more doctors either. And most doctors do go home at night, and hopefully nothing horrible happens overnight. But if they do, they get called. But there are a lot of doctors who could not ever go home. And there were a lot of hospitals that were overwhelmed beyond capacity. And that's where we got into critical problems with people not being able to get the health care that they needed. Now, I said this hypothetical small town with 10,000 people has a small town hospital with 5 ICU beds. Well, my small town doesn't even have a hospital. So this is really quite an optimistic scenario, actually. And I participated in what's called pandemic summits, where we did all these numbers and we calculated the kind of problems we were going to have. And it was terrifying, frankly. And into our model, we put in approximately a 5% vaccine refusal rate. We modeled that in with all the other math. And we didn't really expect to see the degree of misinformation coming out about the COVID vaccinations that we did see that caused vaccine refusal to be so much higher. So I know what you all are really wanting to hear about next, and that is myocarditis. Now, what is myocarditis? And does the COVID-19 vaccination cause myocarditis? The answer is myocarditis is an inflammation of the heart. Sometimes it also, in fact, affects the bag that surrounds the heart. It's an inflammation of the heart. It can be very, very mild, or it can be deadly, okay? So the people who are most likely to get myocarditis that we know of from history are young males. So throughout history, ever since I've been a physician or ever since I went to medical school, we learned how young men typically will get myocarditis. And some of the viruses that cause myocarditis include adenoviruses, hepatitis viruses, herpes simplex viruses, parvoviruses, and hepatitis viruses, and smallpox too. But one of the viruses that causes more myocarditis than we've seen in a long time is actually COVID-19. Infection with COVID-19 causes a lot of serious myocarditis. So we would expect the vaccine to cause myocarditis, because if myocarditis is inflammatory, caused by a viral infection and our body's immune system reaction to the virus infection, we would expect that when we mimic the body's immune system response to an infection, that we will also see myocarditis. And that is the case. We have seen myocarditis after the COVID-19 vaccination. If you're going to get myocarditis, you will get it anywhere from 4 days after the shot to 28 days after the shot. Any type of adverse reaction that you're going to get from a vaccination will typically occur within the first 2 months. And the first week after the shot is the most common time for vaccine side effects to show up. So we do know that COVID-19 does cause myocarditis, and the COVID-19 vaccination does cause myocarditis as well. So how much myocarditis and who is at risk? Okay, that's the question. It turns out that every person has a different risk. If you're a woman over 40, like I am, you'll find that your risk of myocarditis from the vaccination is extraordinarily low. But if you do get myocarditis from a secondary infection with COVID after having been vaccinated, your risk of myocarditis is cut in half. So the vaccine is highly, highly protective against myocarditis for people in my group of people, women over age 40. Now, what about men under age 40? Men under age 40 are at very low risk from COVID itself, unless they are obese or have medical problems. But they are at higher risk from myocarditis. And indeed, they are at higher risk from the vaccine myocarditis than they would be from COVID-19 itself. So most of the people who have had myocarditis, it's been very mild with complete recovery. But we do want to minimize this side effect as much as possible. So as the vaccine becomes less effective, as the virus mutates and mutates, it's going to be increasingly challenging to predict whether or not particularly young males should be getting further booster shots, for example. But for older people, all the data we've seen so far, especially anyone over 40, we can see that vaccine actually is protective against myocarditis and helps to protect and prevent people from getting the cardiac problems that they would have gotten had they simply gotten the native virus. So this information I've gotten from 45 million people who were vaccinated in the United Kingdom. And this is some data that came out a couple of months ago in a reputable journal. So these are the type of articles that we believe and we trust. They are articles that we follow and that we adjust recommendations based on these. But the idea that people are dying like flies or dropping dead, or that they're going to die in the future from the COVID-19 vaccination are completely and utterly false. If you've been vaccinated for COVID-19 and it's been more than 2 months ago, your risk of having a vaccine-related complication is pretty much zero at this point. And whatever was in your body is gone, and you simply are left with some memory cells to prevent the next infection a little bit more, okay? So that's a little bit about myocarditis and the COVID-19 vaccine. I think there's more things we could talk about on this topic, but that's all the time we have for today. So thank you so much for listening, And hopefully we can bring up more on this topic next time. Welcome to Speak Life. And remember, don't forget to speak life into someone's world today. And see you next time.
Tune in next time for Speak Life with Dr. Amy Chai at ctpolitics.tv.